All right, guys. We have an electric dipole with minus q and plus q charge. These results which I'm about to derive, we need to remember them. Okay, remember that you need to remember them. The distance between the dipole is 2a, half a, half a. Let's say I take a point M on the axis of the dipole where the agenda is to find the value of field. On paper, it's the simplest possible application of superposition principle. Find the electric field due to positive charge, find the electric field due to negative charge and add them vectorially. And that is precisely what I have done. This is the electric field due to positive charge, E plus. What's the value? KQ upon x minus a whole square. This is the field value by negative charge, the value KQ upon x plus a whole square. Since the direction of both the fields is opposite, so to find the resultant, I subtract their magnitude. What I have is a 4kqax upon x minus a square, x plus a square. Can I write this further as 2k q times 2ax whole upon x square minus a square whole square? Allowed? What is this, guys? What is q times 2a for the dipole? Dipole moment. Why did I do that? For a reason. And the reason is this. The reason is E net comes out to be 2kxp x square minus a square p. Look at this. This q into 2a, I am substituting as p, and look what happens. It becomes 2kxp x square minus a square square. What's the benefit? The benefit is I actually define the direction of the field also. Can you see your E net? Where is the dipole moment direction? The dipole moment direction is this. This is your P bar. Always from negative charge to positive charge. Can you see your direction of net electric field on the axis point is along P bar? Yes. So you can say E net is 2kxp upon x square minus a square square. Question. What if the point taken was on the left side and closer to the negative charge? Then will it be opposite? No. Because in that case, your E minus value will be more than E plus value and the E net happens to be again along the axis. In other words, along the axis of an electric dipole, the direction of net electric field is always parallel to the dipole moment vector. Understood? E axis is always along the dipole moment vector. Understood? Perfect. The expression is fine. Let's go ahead. Take a special case. What if this A value, what was A value? A value was the half of the distance. 2A was the total distance. What if it's much less as compared to X? And this is a special case, but not so special because in the very definition, if you remember, I took A to be small. So if A is much less than X, what happens, guys? Your X square minus A square in the denominator approximately becomes what? Just X square. And your expression comes out to be 2kp by x cube. I cannot stress on how important this expression is. Let me prove it to you in the next 2 minutes. You have expression for E net as 2kp by x cube. Is this dimensional electric field or not? Yes. Is 2 a constant? Yes. Is k a constant? Yes. Is p a constant for a given system? Yes. You know what you just had? You just proved that E is proportional to the cube of 1 by x, or E is having an inverse cubic relationship with x. But for a point charge, it has a inverse square relationship. 2 point charges separately are having an inverse square relationship with electric field with x. But 2 point charges just separated by a small distance together are producing an electric field. Being a neutral system, first of all, they're producing electric field. On top of that, it's inversely cubic relationship with x. This is the mathematical definition of electric dipole. Any electrically neutral system, mark my words, any electrically neutral system which produces an electric field around in the space which varies inversely cubic with the separation distance is called an electric dipole. How about that?